position of maxima and minima. Let the P point of mth of the bride, let the P point of the Fringes, let the P point of the position mth, let the P point of the position m, let the P point of the position m, let the P point of the position m, position of maxima and minima, maxima and minima and minima, maxima and minima, position of maxima and minima. Let the P let the P be position of mth Fringes order of bride, BRIGH, bride Fringes on the screen then d sine theta is equal m lambda if theta value is so small, if theta value is so small, then sine theta is equal tan theta, or d sine theta tan theta is equal m lambda, integers lambda. आगे क्या होता है? If tan theta is equal to y by L, then y by L, then I don't know, y by L, then d y by L is equal m lambda, hence y is equal m by L lambda by d. Equation 4. ठीक है. Equation 2. Equation 3. EQU4 gives gives the distance distance gives the distance of m bridge of m bride Fringes from the center, from CENTER, center of screen, of SCREEN screen, center of screen. Similarly similarly, for the position position of mth order of dark Fringes, order of dark Fringes minima on screen, comma we can get क्या कहते हैं y is equal 1/2 m plus 1/2 L lambda by d, equation 5. This equation THESE, this equation EQUCATION equation allow you to calculate these equation allow you to calculate based on the position. This equation allow you to calculate the position. You calculate the position of maxima and minima, maxima and minima on the screen in the SCREEN screen based on the known value of d, l and lambda. Note that the center maxima CENTRAL central maxima MAXIM maximum 0, m is equal 0 and y is equal 0. Position of maxima and minima. Let P is the position of mth order bright on screen, then D is equal sin theta m lambda. If theta is very small, then sin theta is equal tan theta, then sin theta is equal tan theta, then sin theta is equal tan theta, then sin theta is equal tan theta. Then sin theta is equal tan theta, then sin theta is equal tan theta, then sin theta is equal tan theta. This equation allow you to calculate the position of maxima and minima on screen based on the knowing value of D and L. Based on the value of knowing value of D and L. This equation allow you to calculate. Let P be the position of mth bright Fringes on the screen. Then D sin theta is equal m lambda. If theta is very small, then sin theta is equal tan theta. Hence, delta d tan theta is equal m lambda, as tan theta is equal y by L, then D is equal y by L, m is equal m by lambda, y is equal m L lambda by D. Equation 4. Equation 4 gives the distance of bright Farigens, bright mth Farigens, bright mth Farigens from the center of the screen gives the m Farigens from the center of the screen Farigens from the center of the screen. Let P similar from the position mth order Farigens on the screen and Farigens on the order of the screen. Similarly, from mth, equation 4 gives the distance of mth bright Farigens from the center of the screen, bright m center from the screen, bright m from center of the screen, bright m from the center of the screen. Similarly, the equation 4 gives the distance distance m bright Farigens from the center of the screen. Similarly, from position m order dark Farigens on screen, order dark Farigens from screen, we get y is equal m by 1 by 2 m is equal 1 by 2 lambda L by D. Equation 5. This equation allows you to calculate the position of maxima and minima. This equation allows you to calculate the position of maxima and minima. This equation allows you to calculate the position of maxima and minima. This equation allows you to calculate the position of maxima and minima on the screen based on the knowing value of D and L, based on the knowing value of D and L. This equation allows you to calculate the position of maxima and minima on the screen based on the knowing value of L and D and L, and lambda. This equation allows you to calculate the position of maxima and minima on the screen based on the knowing the value of L, D, and lambda. L, D, and lambda. L, D, and lambda. Note the maxima m is 0 and y maxima. Note that the center maxima m and y will always be at y is equal 0. Okay. Maxima and minima. Let point be position of maxima and minima. Let P be the position let P be the position of nth order of nth order of bright Farigens on the screen. Full stop. Let M be the Farigens of the screen. D sin theta is equal m lambda. इक्वेशन 1 ही है ये तो ठीक है. Alright. Theta is so very small very small लिखा हुआ है, very small. Hence then sin theta is equal tan theta, so d tan theta is equal m lambda, since tan theta is equal y by L, therefore dy by y by L is equal m lambda, or y is equal m by L lambda by d. Equation 4 gives position of mth order of bright Fringes on central 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 of SCREE and screen. Similarly position of m order of dark Fringes on the screen क्या लिखते हैं, y is equal m plus 1 by 2 L lambda by d. Equation 5 शुरू कैसे होते हैं. These equation allow you to calculate maxima and minima on screen. फिर इक्वेशन क्या हो जाती है, डेड. Based on value of d, L and lambda. The value of CENTRAL central maximum m is equal 0 and always and always be at y is equal 0. rough, treat it like rough. Fringes spacing. Fringes spacing. The distance Fringes spacing. The distance between two constructed bright and dark fringes is called two consecutive नहीं है consecutive bright and dark fringes is called Fringes spacing. For bright fringes the Fringes spacing is the bright between the distance between bright consecutive the distance between two bright and dark fringes on is called Fringes spacing. Fringes spacing. Distance between two consecutive bright and dark fringes is called Fringes spacing. For bright fringes, the Fringes spacing is distance of m bright fringes from the center of screen y is equal m lambda l by d. Okay, distance of m plus 1 bright fringes from the center of the screen y is equal 1 plus m 1 m plus 1 y m plus 1 y m plus 1 l lambda by d. Okay, lambda by d. The Fringes distance between two constructive bright and dark is Fringes spacing. The distance between two constructed bright and dark is called Fringes spacing. The distance between two consecutive bright and dark is Fringes spacing. The distance between two bright and dark consecutive. The distance between two bright and dark consecutive bright and dark is called Fringes spacing. The distance between two consecutive bright and dark is called Fringes spacing. The distance between two bright and dark 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 the distance between two bright consecutive the distance between two consecutive bright and dark fringes is called Fringes spacing. For bright Fringes spacing is fuck it. For Fringes spacing, the distance between the distance 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 between bright and dark between two consecutive Fringes, two consecutive bright and dark Fringes, bright and dark Fringes on Fringes is called Fringes spring. Fringes spring. The Fringes space PAC spacing. The distance between two consecutive bright and dark Fringes is called Fringes spacing. The distance between two consecutive bright and dark Fringes is called Fringes spacing. For bright, for BRIGHT bright Fringes, FRINGES Fringes, comma the bright space, the Fringes spacing is PACING spacing is the distance 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 of mth the distance of mth bright Fringes mth bright 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 Fringes from the center of the screen, from center of screen of SCREE and screen is equal to YM is equal MYL by D. Okay, L by D. The distance of M bright from the center of the screen. The distance of M plus 1 bright Fringes from center of screen, from center of SCREEN is equal YM plus 1 is equal M plus 1 YL by D, lambda by D में lambda L by D. L by D Fringes spacing FRIN Fringes spacing 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 Fringes spacing Fringes width Fringes width FRING Fringes WIDTH width Fringes width of bright Fringes of BRIGHT bright Fringes FRGES Fringes delta Y is equal YM plus 1 negative YM. तो ये लिखेंगे डेल्टा Y is equal इज इक्वल, अब इसकी वैल्यू लिखो m प्लस 1 लम्डा l बाय d, ये कट जाएगा, माइनस m लम्डा l बाय d। ओके, और मल्टीप्लाई भी हो रहा है ना, फिर ये मल्टीप्लाई करके लिखते हैं। डेल्टा y इज इक्वल m लम्डा l बाय d, फिर ये हो जाएगा प्लस लम्डा l बाय d माइनस m लम्डा l बाय d, ये दोनों कट जाएंगे। CUDD कटिंग m लम्डा l बाय d, hence डेल्टा y इज इक्वल लम्डा l बाय d। इक्वेशन 6। इक्वेशन 6 उसमें क्या है, इक्वेशन 6, how will we share equation 6? Distance of mth dart, for against distance of mth dark furgens from center of the screen, from center of the screen ym is equal, सेम वही पोर्शन है वाले ना रिवर्स हुआ है, m प्लस डायरेक्ट लिख सकता मैं 1 बाय, इधर क्या फॉर्मूला y डेल्टा, यहाँ ym बाय l लम्डा l बाय यहाँ क्या आता है, आई डोंट नो, d, और यहाँ आता है ym प्लस 1 इज इक्वल m लम्डा l बाय d। ओके, और यहाँ लिखते हैं डेल्टा y इज इक्वल, अब क्या फार्मूला इसका, फार्मूला है यहाँ, फार्मूला है इसका क्या, ym प्लस 1 माइनस ym, तो ये रहेगा डेल्टा y इज इक्वल, अब वैल्यूज लिखते हैं यहाँ, पहले m सेम बुलशिट, नो प्लस m प्लस 1 प्लस 1 by 2 y m plus 1 plus 1 by 2, ठीक है, माइनस डेल्टा लम बाई डी, ठीक है, ये हो गया, माइनस m प्लस 1 लैम्डा L by D. All right. M del L by D plus L by D lambda delta में lambda L by D plus lambda L by D L by 2D minus M plus 1 ऊपर 2 लिखा है by 2 by D minus lambda D y is equal to y delta y is equal lambda L by D. The distance of m dark Fringes from the center of the screen ym is equal m plus 1 by 2 delta L by delta D. Distance of 1 m plus 1 dark Fringes from the center of the screen is equal y m plus 1 is equal m plus 1 by 2 delta L by D. Similarly, Fringes spacing of the dark is बाकी ऊपर लिखना Fringes spacing between bright and dark is same. Between bright and dark are same. अब ये पूरा वो बनाना है Fringes spacing 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 delta y is equal lambda L by D depend upon D E P and D depend upon wavelength of light, wavelength of light of LIGHT, light, wavelength of light, delta y proportional to lambda फिर सारा ही उनका distance based light in screen, distance between slide and screen, y delta proportional to L, same here, distance between two slides, it's weird people say slide, slit, because everybody's saying slit, not slide. Slide, SLIT, slide, delta y proportional to 1 by this. Okay. If the wavelength of a light increases, the Fringes spacing also increases. Okay. Alright. Are you doing 40 minutes? I'm fucking tired. Alright. Right. Okay, the distance between two consecutive dark, bright and dark Fringes is called Fringes spacing. The distance between two and dark consecutive bright and dark Fringes is called Fringes spacing. The distance between two bright and dark Fringes is called Fringes spacing. The distance between two consecutive bright and dark Fringes is called Fringes spacing. For bright and dark Fringes, the Fringes spacing is the distance of mth bright Fringes from the center of the screen. Ym is equal m lambda L by d. The distance of m plus 1 bright Fringes from the center of the screen. Ym plus 1 lambda L by d. Fringes spacing, Fringes width of a bright Fringes is equal Fringes spacing, Fringes width of a bright Fringes, Fringes spacing, Fringes width of bright Fringes, y delta y is equal y m plus 1 minus y m, y delta y is equal m plus 1 lambda L by d by m, m lambda L by d, y is equal m lambda L by d plus L by d negative m lambda L by d, m lambda d कट जाता है, hence y is equal L lambda L by d. Equation 6. The distance of m dark Fringes from the center of the screen is equal m, ym is equal y m plus 1 by 2 lambda d square lambda L by d. The distance of m plus 1 dark Fringes from the center of the screen, ym m plus 1 by 2 lambda L by d. Similarly, ठीक है. So the Fringes spacing between two dark and again in the center. Okay. Upon wavelength distance between two slide and screen. In 1801, Thomas Young performed the interference experiment to prove the nature wave of light. In 1801, Thomas Young performed the interference experiment to prove the natural wave of light. Young's double slide is the evidence of true the wavelength of screen having two narrow slide is illuminated by a beam of monochromatic light. The principle of this experiment is based on the division of wavefront. Monochromatic light passes through two narrow slides, producing semi-circular waves. That overlap and interfere on the screen placed behind the slide. S2, slide S1 and S2 are narrow, so the light spreads on, deflecting on the each slide. Two slides generate two coherent light sources, causing interference in the constructive form a bright constructive interference and a destructive interference pattern on the screen. Path difference: the wave from the slide S2 has to travel slightly larger than from the S1 to reach the point P on the screen. The difference in this distance is the path difference. The path difference between two waves proportional to the path difference expressed in terms of wave lambda. The path difference between two waves proportional to the path difference expressed in the wavelength in terms wavelength. The wavelength from the S2 has to travel slightly larger than S1 to reach the point P on the screen. The difference in this distance is the path difference. The wavelength from the S2 has to travel slightly larger than that from S1 to reach the point P on the screen. The difference is the distance is the path difference. The phase difference between two waves proportional to the path difference expressed in terms of wavelength lambda. The phase difference between two waves proportional to the path difference expressed in terms of wavelength lambda. The separation distance between two slides AB is equal to D. The distance between slide and screen L. The distance of point P from the center is on the maximum screen Y. Draw a perpendicular from A on BP. Draw a perpendicular. Draw a perpendicular from A on BP. AP is equal to CP. Therefore, BC is the path difference between two waves. Here, therefore, BC is the path difference from delta ABC from delta ABC. Sin BC is equal to AB. Hence, the path difference BC between two waves reaches the point on the center of the screen. On the screen from two slides in BC is equal to AB sin theta. AB is equal to D. Path difference is equal BC is equal to D sin theta. Equation 1. Constructed interference occurs when the wavelength series overlap. The constructed interference occurs when the wavelength series overlap, resulting in maximum on the screen. The path difference is an integer multiplier of the wavelength. Constructed interference occurs when the light wave of series overlap, resulting in maxima on the screen. With the path when the path difference is an integer multiplied by the wavelength. Path difference is equal to m by L. D sin theta is equal to m by L. Equation 2, where m is the integer 0 plus minus 1 2 3, representing the order of maxima. Center maximum is 0 order. When m is equal plus minus 1, then two Fringes are obtained above 1 and 1 below center point 0, which is called 1th order of the bright, where m is the integer representing the order of maxima on the screen, where m is the integer 0 plus minus 1 2 3, representing the mth order of maxima. Order of the maxima. Center maxima is the order when m is equal plus minus 1, where m is an integer 0 plus minus 1 plus minus 2 plus minus 3, representing the order of maxima representing the order of maxima. The center maxima is the order is a 0. The center maxima where m is the integer of where m is the integer where m is the integer Construction interference occurs when the light wave series overlap, resulting in maxima on the screen. When the path difference is integer, multiply the wavelength. Path difference is m by lambda or d sin theta is equal m by lambda equation 2, where m is the integer of the center, representing the order of maximum. Center maximum is 0th order. If m is equal plus minus 1, then two Brighton Fringes are obtained, one above and one below from the center 0.0, which is called first order of the Brighton. Structural interference happens when the series overlap. Series of the one wave cancel out to another, resulting in dark minima. Structural interference happens when series of one wave cancel out each other, cancel out the torque of other, when the m is the integer, 0 plus minus 1 to 3, representing the order of maxima. Center maxima is the zero order. When m is equal plus minus 1, the two bright Fringes are obtained, one above, one below the center point 0. m is an integer, 0 plus minus 1 to 3, representing the order of the maxima. When m is the order 0 plus minus 1 to 3, representing the order of maxima on center maximum is the 0 order. Representing the order of maxima, center maxima is 0 order. When m is equal plus minus 1, then 0 bright Fringes are obtained, one above, one below the center point 0 below the center. When m is the plus minus, then two Fringes are obtained, one above, one below the center point 0, which is first order of bright Fringes. The structural interference happens when the series of one wave cancel out the torque of another, resulting in dark minima. This occurs when the path difference is odd, multiply of the one of the half lambda wavelength, aq lambda. This occurs when path difference is odd multiply by one, or multiply of half the wavelength, i.e. path difference is equal m plus 1 by 2 lambda, or d sin theta is equal d sin theta is equal m plus 1 by 2 lambda, equation 3, where integer is still 0 plus 1 plus minus 2 plus minus, representing the order of minima. First minima m is equal to second minima m third 2. Position of let P is the position of mth order of bright Fringes on the screen. Let P is the position of mth order bright Fringes on the screen. Let P is the position of nth order Fringes on the screen. Let P is the mth order of Fringes on the screen. Let P nth order of center of the screen. Let P is the position of m order Fringes on the screen. Then let P is the position of mth order Let P is the nth order. Let P is the nth position of order. Let P is the position of nth order bright furicles on the screen. Let P is the position nth of order bright furicles on the screen. D sin theta is equal m lambda. Let P is the position of nth order of bright furicles on the screen. D sin theta is equal m lambda. If theta is so small, sin theta is equal tan theta. So d sin tan theta is equal m by lambda, as tan theta is equal y by l. D y by l is equal m lambda, or y is equal m l lambda by d. Equation 4 gives the distance of m bright furicles from the center of screen. Similarly, position m order of dark furicles on the screen. We get y is equal m plus 1 by 2 lambda l by d. Equation 5. The equation allows you to calculate the position of maxima and minima based on the value of l lambda, l, d, and lambda. Note the center maxima is equal 0 and equal 0. Furicles spacing. Furicles is the distance between Furicles spacing is the distance between two consecutive bright and dark by furicles is called Furicles spacing. Distance between two bright and dark furicles. For bright furicles spacing is bright a distance of mth order bright furicles from the center of the screen. The distance of mth order bright furicles from the center of the screen by m is equal m is equal m by m lambda l by d. Distance of m plus 1 bright furicle from the center of the screen is equal y. M plus 1 is equal m plus 1 lambda l by d. Furicles spacing width of bright furicles y delta y is equal y m plus 1 minus y 1 y m plus 1 minus y m delta y is equal m plus 1 delta l by d minus m delta lambda l by d. Thomas Young पूरा लिख दे. Thomas Young perform. Thomas Young perform. Fun. I don't know. Thomas Young perform. I don't know. Thomas Young perform. The interference meant to prove wave nature of light. Young's double slit is the evidence of wave nature a sequence having two narrow slide to illuminated by a beam of monochromatic light. Monochromatic light. I don't know what the fuck it's called. Monochromatic light. Light passes through through monochromatic light passes through two narrow slide. Monochromatic light passes through two narrow slide on slide producing semicircular 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 from the center of the sequence. On the screen, the semicircle on the screen semicircular on the screen with the overlap and wave that overlap resulting screen behind. मुझे एक चीज चेक करनी है, प्रिंसिपल वाला है behind behind. In the slide, the principal of this experiment is based the principle of this experiment is based on division of wavefront is two slide S1 and S2 are narrow, R N A double R O W narrow. The light spreads out on the SCREEN screen, spreads out on the screen, spreads out on the screen, spreads out on the screen. Spreads out on the screen. I don't know. Spreads out on the screen. Okay, I really don't know. Spreads out on the screen. Defect DIFFRAC, affecting each slides to narrow slide generate 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 two coherent sources that I really don't know. Two coherent sources that overlap that overlap and interfere in terms of bright Fringes constructive Fringes interference and dark Fringes F. This truck reflector interference and on the screen, comma, okay, power difference. Difference. I really don't know. So it's the wave, of slide S2 has to travel slightly SLIGHT slightly larger than that slide from slide S1 from to reach the point P on center of SCREEN, the EIFFERENCE difference between the distance is the path difference, DIFFERENCE difference, the phase of a distance between two waves is proportional proportional to the path difference proportional to the phase of this proportional to the path difference proportional to the path difference expressed in terms of proportional to the path difference expressed in terms of waves, wave LENGTH wavelength. Lambda separation between slides is equal AB is equal D distance between the slides and point P of the sequence and point P of sequence is equal L distance between point P and center of sequence N. is equal to Y. ठीक है perpendicular draw a perpendicular perpendicular point P AP is equal CE TP BC is the path BISSERENCE difference path sin theta is equal BC by AP theta A B is equal D path is equal B C is equal D sine theta equation 1 consecutive interference consecutive interference OCCUR occurs when cirrus overlap RESULTI resulting in bright maxima on SCREE and decrease the power difference is integers multiply wave consequent interference को m lambda pi लेकिन क्या आता है डिस्ट्रक्टिव इंटरफेरेंस constructive with a variable d sin theta d sin theta is equal m lambda equation 2 the m is integers 0 comma plus minus 1 comma 2 comma 3 up to so on representing the order of tag difference, the order of bright maximum central M-A-X-I-M-E-N. Central maximum. Central maximum is equal to 0. I don't know. Maximum 0th order 0 order per second. Zeroth order when 2 bright fragments when 2 bright fragments are one above A, B, O, V, E, one above and one below the 0 path, which is order 1 as bright fragments. Direct integer name. This truck is fragments. Thought is this truck minima. This occurs when power difference multiply half HL is half of the half of I don't know half of मुझे खुद भी नहीं पता सोच multiply the half of odd odds d sin theta is equal m plus 1 by 2 lambda. Equation 3. Equation 3. M is still integer 0, plus minus representing order of dark minima first minima is 0, second minima is equal 1/3, two full stop. The position of maxima and minima. Let P be the point. Let P be the point of let P be the point let P be the position of nth order. P be the point of nth position of buried maxima AXIMU maxima from divergence from center C and T are as center of SCREE in screen. position of the center. So यहाँ तक ही. Let P be the end position of the center of the bright frequency from the center of the screen. Okay. Okay. D sin theta is equal m lambda. ठीक है, ये हो गया. Theta is so very small, very good, very small. Then sin theta is equal tan theta, so ये देगा d tan theta is equal m lambda, so tan theta is equal y by L, और d then dy by L is equal m lambda, और y is equal m L lambda by d equation. जो दिमाग खराब किया है. Yeah, kill me. Equation 4. Equation 4 is the position of bright Fringes from center screen, from central screen आगे क्या करते हैं. The point m plus 1 position of dark fringes from center of central screen y is equal m plus 1 L lambda d equation 5. एक पूरा एक हुआ है, इसका लाइन है प्रॉपर. Equation 4, equation 5 This equation allow you these equation this equation allow you to calculate the position of maxima and minima based on values of L, D and lambda. The m is equal 0 is true, the y is equal 0. Fringes spacing. Fringes spacing. Fringes spacing कैसे स्टार्ट होते हैं कहते हैं Fringes spacing, the distance between two consecutive the distance between two successive bright and dark Fringes is called Fringes spacing. Fringes spacing. Fringes spacing for bright Fringes for bright Fringes. The Fringes spacing is the distance of mth bright Fringes screen Fringes from center of the screen is equal y m is equal m lambda a by d. Okay, the distance of m plus 1 bright for from central of screen, center of screen, center of screen, I don't know. Y m plus 1 is equal m plus 1 L lambda d del y is equal y m plus 1 minus y m delta y is equal y m plus 1 m plus 1 L d L lambda by d minus L lambda by d. I fucking hate my life for this. M lambda L by d by lambda by dl lambda d minus plus L lambda d minus m lambda d. यह हो जाएगा डेल्टा y इज इक्वल m lambda by d. इक्वेशन 6 लिखना भूलिए। इक्वेशन 6 for from center again from m plus 1 by 2 है। Two is equal m plus 1 by 2 lambda L by D, ठीक है, माइनस m प्लस 1 by 2, यहाँ क्या था, लैम्डा L by D इज इक्वल m लैम्डा 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 L by D plus lambda L by D plus lambda L by 2D, ठीक है, माइनस m lambda L by D L by D minus lambda L by D 2D y del y is equal lambda L by D Fringes spacing of both maxima and minima are same, ये हो गया। आगे क्या था, I don't know, think I really don't know. Yeah, fighting. Depends. Between